All right. Welcome, everybody. I'm so excited that we could have another still COVIDing chat and info session. And tonight, I am really super excited about this one. I know you guys have seen me posting about this. And when I tend to find something I think is really good, I tend to start being maybe even a little obnoxious about it. But for me, there's some things during the pandemic, thinking back from like 2020 until now, that have really been game changers. So things that have allowed like me to feel an extra layer of security, or an extra layer of mitigation for my family, that I felt like really made a difference when we were able to adopt it. So things for me like far UV have made a big difference for me personally. Having a PAPR, of course, when we learned about just air filtration, then we got the vaccines, and then we all learned how to upgrade our mask and how to do home fit test. And so we've sort of been through this progression, right? Where we felt like really helpless about, especially those of us who are immunocompromised or who have loved ones who are, felt really helpless and sort of trapped in how to deal with this ongoing pandemic. And then as the pandemic denial got worse and worse, then all of a sudden it felt like we were running out of options. And then lately, I've sort of felt like, even though that hasn't really stopped, we've started to get some really good tools. And they're not the tools originally that our government said, oh, you got the tools. No, they're tools that like dedicated, citizens, innovators thought of to help keep our community and our society and themselves safe in the pandemic. And I really feel like Profi is one of those. When I, first heard about Profi, because Alex reached out to me, and then when I started looking at it, I thought, wow, this is really a game changer. Like, I mean, obviously you guys know, like I usually use Xclear, but we have like Innovid, and we have, Sanitize, and we have all of these different nasal sprays that are out there. And we have all these debates about like how to layer them and which one to use first and what's the most cost-effective option and what works best. But when I started looking at the science behind Profi, my first thought was, this is really something different. Like this is something that I can really sink my teeth into as a better option. And I think by the time we're done talking today, you'll understand why I think that. I'm not going to tell you about it. I'm going to let these guys who actually developed it and brought it to us. Profi's a relatively new nasal spray on the scene, but I like the data, I like the science. These guys have been super generous to me, because you guys know too, once I find something, then I have a million questions, right? And so I'm going to go and dig and ask and until I'm satisfied. And then I'm going to try it myself before I bring it to you guys, because I really feel like that I have a certain amount of, responsibility to you to make sure that we only have those sound products in here and things that I could, trust to use myself and my own family. So I'm going to say that Profi has my stamp of approval, and for whatever that means. You can return it for what you paid for it. but I really do think it's a game changer in terms of nasal sprays. I think it's a game changer in terms of layers of mitigation. So I'd like to introduce Alex Revelos, who leads Akita Biosciences. That is the Harvard Medical Technology spinout that is producing Profi. And then one of the lead scientists as well, Dr. Nitin Joshi, who is an assistant professor at Harvard Medical School. And again, like I said, is one of the lead developing scientists here for Profi. So welcome, guys. Thank you so much for being here and taking our questions and taking the time to tell us about Profi today.
Thank you, Kara. We can't wait. Let me share my screen here. And before we get going, we just want to give a special thank you to Kara and Sandy, who have graciously hosted us tonight. And so there's a lot that goes on behind the scenes to coordinate these events and maintain such a vibrant community. So we're very grateful for the opportunity, and we're grateful for the opportunity to speak with everybody. So thank you so much for taking your Friday. For me, it's Friday night. I don't know where everybody's located in the world, but we're truly delighted to be able to share a little bit more about who we are and introduce Profi Nasal Spray and all the scientific rigor that went into creating the product. So in terms of our agenda, we'll talk again about who we are, our backgrounds, really go into some depth in terms of our founding story and some of the projects that we're working on before the pandemic hit that really helped to kind of pave the way for Profi. And then we'll go deep on the science. I'm told this group appreciates the science, so that's really music to our ears. We'll go deep on science and then open it up for Q&A at the end. And we do have a special offer for those attending the online session if you make it all the way through. Oh, and one disclaimer. So this presentation is provided solely for educational purposes and should not be construed as medical advice. Always consult a qualified healthcare professional. So my name's Alex. I lead Akita Biosciences. I'm one of the co-founders. We are, of course, the makers of Profi Nasal Spray. I'm a biomedical engineer by training, and I've spent my career in healthcare. The last 8 years have specifically been in respiratory hair, respiratory health, respiratory care. And in a capacity of helping to build and commercialize new products focused on solving unmet needs. So for example, previously I was working to commercialize an SpO2 sensor that actually sits on your nose. It's a highly vascularized area where you can get a fast and reliable SpO2 signal. Handheld breathing devices that help to create back pressure to reinflate the air sacs within your lungs and of course, improve oxygenation. Even hydrogel cushions that sort of rest on the bridge of your nose and cheeks for individuals that are on non-invasive ventilations and may have frail skin. And so I would just say that during this time, what really struck me was the burden of respiratory conditions. Even just looking in the US, to me, it's kind of interesting that the CDC, they break up acute conditions, so somebody catching the flu, with chronic conditions like COPD. And when you add those two together, in the US, respiratory health as a whole is the third leading cause of death behind heart diseases and cancer. And this is like 2019 data, so take the pandemic out of it. It's always been a big problem. And when you take a step back and look globally, lower respiratory infections are the world's most deadly communicable diseases. And so I just always felt like it was this insidious problem and really wanted to, while creating products for hospitals is great, I really wanted to spend more time promoting healthy lifestyles and trying to keep people out of the hospital to begin with. So that really aligned with our mission at Akita, which is to create technologies that help people live healthy and vibrant lives. So that's me, and I'll kick it over to Dr. Nitin Joshi for his introduction.
Thank you, Alex. I would like to thank Kara and Sandy for really organizing this and giving us this great opportunity to talk to everyone here and share the science, especially because the final paper is not out yet. So we'd love to answer any questions you have. And so I am Nitin Joshi. I am an assistant professor at Harvard Medical School, Brigham and Women's Hospital. I have spent more than 15 years now working as a researcher in the field of biomedical engineering. I did my PhD focusing on inhalation delivery of therapeutics for lung cancer and many other respiratory diseases. Then I moved to Boston and started my postdoc here at the Brigham and Harvard Medical School, where I continued my work on inhalation and nasal drug delivery, and also focused on several different areas. My lab currently works on drug delivery and biomaterials, and nasal delivery and inhalation delivery is one of the major focus areas. So this Profi is one of the technologies that came out of the lab, and we are currently advancing this platform further for delivery of different types of therapeutics for different respiratory diseases, immunomodulation, and other applications. We are also working on some other interesting areas where we are trying to deliver biologics for via inhalation route for different applications, for example, type 2 high asthma, so that we can really maximize the therapeutic effect of all the different types of drugs, as well as reduce the systemic toxicity concerns. Really excited to be here today and looking forward to talking to you more about the product and answer any of the questions you have. Thank you.
Thank you, Nitin. So we've had a ton of people that have been instrumental in getting Akita to where it is today, but I also wanted to highlight one of our other co-founders, Dr. Jeffrey Karp. Jeff is also a professor at Harvard Medical School. He's a distinguished chair of anesthesiology at Brigham and Women's Hospital, and is really recognized as a world leader in drug delivery and tissue adhesives. And I personally admire him for his ability to translate science into impact in the real world. In fact, just actually just yesterday, the Boston Business Journal recognized Jeff as one of their inaugural Innovators in Healthcare honorees. So we're lucky to have him. And let's get moving here. So before the pandemic and really before we created Profi, we spent a lot of time understanding how to deliver therapeutics intranasally. And at that time, we were actually working and experimenting with a biologic. And this particular biologic is an anti-CD3 monoclonal antibody. It's being used or at least tested at least as a treatment for multiple sclerosis. And it's also massive. It's 150 kilodaltons, so significantly larger than some of the other molecules that are delivered intranasally. So we put it here relative to naloxone. It's over 400 times larger than naloxone, and again significantly more challenging. And I always say that really focused us to look closely at some of the underlying challenges relative to intranasal drug delivery. And what that means is we had to figure out, how do you encapsulate drugs within a hydrogel and then tune the spray characteristics, the plume, in such a way to form a uniform coating within the nasal cavity. And then because it's so large, you have to really maximize the exposure time. So, instead of 15 minutes or an hour, it's like, how do you get 8+ hours of contact with the nasal lining? And then, of course, you have to control the release of these large biologics. And so, we really didn't know it at the time, but we built this expertise that really proved to be quite valuable. And then, of course, in March of 2020, everything changed when the pandemic hit and the novel coronavirus. Of course, at that point in time, it really wasn't well understood. At least in the US, we had hospitals that were filling up. And it was really a sense of urgency and concern around this mask shortage. And so Jeff Karp, one of our co-founders, actually got pulled into an emergency meeting at a large health system where they were coming up with contingency plans. And the question was, what are we going to do if we run out of masks? And so, like all good scientists and engineers, we started to, really do our homework. And again, fortunately, we're already built this expertise in intranasal drug delivery. And I'm sure this group knows that the nose is key, right? And so, there's been several, advancements in science. And so we now know that respiratory droplets containing coronavirus, as well as other respiratory infections, they tend to be transmitted through the air, right? So somebody will cough, they'll sneeze, or even just talking and breathing. And, droplets are disseminated through the air. And what the science tells us is they attack the nose. And at this point, the overwhelming evidence points to the nose as being the initial infection site for many respiratory infections. So then we also took a look to see, what were the current solutions and what were the challenges with those solutions. And so, again, we're an organization that's driven by science. We firmly believe that masking is effective. However, it's still not a perfect solution, right? They can, based on the design of the material, the design of the mask itself, how it fits to an individual's face, there can be large gaps that impact the efficacy. And also, as far as I know, maybe the masks have evolved, but you still need to take them off in order to drink or eat. And so masking's great. Unfortunately, still not a perfect solution. We also think vaccines are effective. However, as these viruses mutate and propagate the globe, the efficacy of vaccines tends to diminish over time. And today we need multiple vaccines for each virus, viruses that exist as well as viruses that might be around the corner. And so we asked ourselves, can we develop a nasal spray that complements these existing solutions by shielding the nasal passages and protecting us from both current pathogens as well as any emerging pathogens? And the answer is yes. We think we can. And so with that, I'll kick it over to Nitin.
Thank you, Alex. So, as Alex mentioned, one of the key goals at that time for us was to really come up with a system that can be quickly translated and has and is very safe to be used on a daily basis. So, what we did was, we really looked at the FDA's two important list of excipients or ingredients. One is the inactive ingredient database, and the other is generally recognized as safe compounds of compounds list. So the inactive ingredient database is essentially, if you don't know, is a database of FDA that consists of a lot, like almost like hundreds of different compounds which are present in different types of formulations, like taken nasally, orally, intravenously, etc. And what is the maximum concentration that they're present at? What is the maximum potency or daily use permissible? So we looked at the entire IID and GRAS list, and we identified several excipients, their different combinations and concentrations, and then we screened them rigorously in vitro and in vivo to really optimize some of the key characteristics. The number one thing for us was to maintain to really ensure safety. So the concentrations we looked at for all these compounds were the concentrations which are well below the concentrations at which they are used in humans in the currently available products. And also, we only looked at compounds which are present as excipients in the nasal dosage form. So we did not take compounds, for example, which are used intravenously or orally, because their toxicity their toxic concentrations or safe concentration will be very different compared to when you use them nasally, right? So safety was one of the key things. So we maintained these concentrations well below the concentrations used in humans in the currently available products. We had to maximize the sprayability and the coverage. So when you spray it into the nose, we wanted to make sure that the formulation really forms a uniform coating at the back of your nose, where most of the deposition happens for the respiratory droplets. The number third for us was to really maximize the capture of respiratory droplets in nasal cavity. Now, the reason why this is important is because pathogens are transmitted via large respiratory droplets of the order of 5 to 10 micron size. And these respiratory droplets, because of their aerodynamic properties, get impacted onto a nasal cavity. But there is a chance that these droplets can really bounce off and can enter into your deeper airways. Now, when that happens, your deeper airways also have receptors to infect, although not as many as the upper airway, right? But we are not forming this coating. This protective coating is not going to be formed in your deeper lungs. It can only be formed in your nasal cavity. So we wanted to make sure that our formulation can really prevent the bouncing off of these respiratory droplets, so that we can capture them in the nasal cavity and can neutralize the pathogen there. And the next part was, of course, the physical barrier properties. So once the droplet is captured, can we really prevent the transport of the pathogen across the nasal lining? And then once we have trapped the droplet and the pathogen, can we now neutralize it? And can we have this formulation to have a broad spectrum neutralization property, so that we can neutralize not just SARS-CoV-2, not just flu, but also like other viruses, including RSV, and even non-enveloped viruses, for example, adenovirus, and bacteria, including E. coli, K. pneumonia, etc. And as Alex mentioned, we were already working on a formulation before this that had shown us a really long nasal residence time. So the lessons that we learned there, we took those to design this formulation as well, so that we have a really long nasal residence time of almost 8 hours, so that you can just spray it like twice a day or something like that in the nasal cavity. So here, based on all this rigorous screening, we identified we identified pectin, gelin, PEA, polysorbate AT, and benzalkonium chloride, along with water, to really formulate this system. And each ingredient here really serves a purpose. Pectin has a specific purpose. Gelin has a specific purpose. So if you remove one of the things from one of the components, you're really you will really reduce the effectiveness of the entire formulation. And because this formulation can capture and neutralize the pathogens, we named it as PCANS, or Pathogen Capture and Neutralization Nasal Spray. So I'm going to share some of the data that we generated on this formulation. So As I mentioned, the first most important property of this formulation is to really enhance or maximize the capture of respiratory droplets. Now, to study that, we basically used a 3D printed model of human nasal cavity. It's a very standard model of nasal cavity that is used by pharma companies and biotech companies to study the deposition patterns of nasal formulations. And this has all the intricate anatomical features of the nasal airway. So what we did here was we coated this nasal cavity with either mucus, or we coated it with mucus plus our formulation. And then we connected it to a vacuum pump to apply negative pressure. And the nose side of the nasal cavity was connected to a nebulizer, through which we created these large respiratory droplets that were laden with virus-like particles, and we exposed the nasal cavity for almost 10 minutes. And after that, we looked at the deposition. So we basically rinse the nasal cavity, take the formulation out, and then see how much of the virus-like particles are deposited in the presence of mucus versus in the presence of mucus plus pecans. And as you can see in this data on the right, when we had pecans layer over the mucus layer, the capture of the particles was doubled, which is really critical. And we believe that this particular feature has not been well addressed in other nasal formulation or other chemoprophylactic approaches that are out there, including Sanitize, Xperia, and other technologies. So here is you can see in this particular example. So this is a separate study where we actually wanted to observe the uniform coating in the nasal cavity. So we tag the formulation with the red colored dye, so you can see how it spreads on the inside of the nasal cavity. Next slide, Alex. Thank you. So once the formulation captures the respiratory droplets that are laden with pathogens, the next step is to prevent the transport of the pathogens that come out after the droplet is burst. So to study the property of our formulation, to be able to prevent the transport of these pathogens, we took a transwell. So it's essentially a cell strainer. You can consider this as a strainer with a mesh with a 17 micron pore size. So if you add anything, on the top of this, or any like virus or bacteria, they are free to sort of percolate down and you can quantify them. So in this particular case, we coated this with mucus, because mucus also, sort of helps to prevent the transport of the pathogens via nasal cavity, but it's not very effective in doing that, especially for different types of pathogens. So in one case, we coated this transwell with mucus, or we coated it with pecans. And then we added the virus or the bacteria at the top, and after 4 hours at the bottom, we looked at the transport of the pathogen. We quantified the amount that went to the bottom chamber. And as you can see here, although mucus helped in preventing the transport of some of the viruses and bacteria to some degree, it was not as effective as pecans. When we had pecans coating, we saw almost 99.99% reduction in the transport of all the different type of viruses and bacteria we tested, including influenza A, SARS-CoV-2, K pneumonia, RSV, adenovirus, E. coli. In fact, it was so effective that when we added a small molecule dye, the size of that small molecule dye was 1,000 times smaller than the size of a virus or a bacteria. Even in that case, we were able to see almost 0% dye in the bottom chambers. This really shows the effectiveness of this particular formulation to prevent the transport of any pathogens added on the top. Now, the final step in this entire multi-model approach is really to neutralize the trapped pathogen. And neutralization we define as a process by which the formulation either kills or destroys the membrane of the pathogen, or it impedes the entry of the pathogen into the host cell by binding to a certain receptor or by binding it via an electrostatic interaction. So in this particular study, what we did was we incubated the pathogen with the formulation for 10 minutes or 30 minutes. And then we infected and then we infected the pathogen and infected the host cells with the pathogen, and we looked at the percent reduction in the pathogen load in the host cell. And as you can see here, when we treated the viruses or bacteria with pecans for 10 or 30 minutes, we were able to see greater than 99.99% reduction in the pathogen load in the host cell. And this was observed across all the different type of pathogens we tested, be it enveloped viruses like influenza A, SARS-CoV-2, or non-enveloped viruses like adenovirus, or bacteria like E. coli or Escherichia pneumonia. Then, as we mentioned before, we had already learned a lot of lessons from our previous study about, increasing the residence time of the nasal formulations in the nasal cavity, and we used those principles to really prolong the residence time of this formulation or exposure time of this formulation in the mouse nasal cavity. So, in this study, we basically added a fluorescent dye into the formulation and then instilled the formulation into the mouse nasal cavity, and then tracked the nasal cavity at different time points to look for the fluorescence from the formulation. And as you can see here, we were able to observe the fluorescence from the formulation for up to 8 hours, which really shows that the formulation can last in the mouse nasal cavity for almost 8 hours, which is very promising, because we were quite surprised actually initially when we were doing the previous project, like how are we getting this such a long residence time, which was never reported. So we digged into the mechanism. We have more mechanistic studies that we have done, which are actually included in the paper, which is on bioRxiv right now. And this is, to the best of our knowledge, the longest exposure time that has been demonstrated for any nasal formulation previously in the mouse nasal cavity. Now, the reason why we think that this will really work in a similar way or in a better way to some extent in the human nasal cavity is because of the fact that the clearance in the mouse nasal cavity is actually faster than the human nasal cavity. So something that lasts for 8 hours in the mouse nasal cavity is probably going to last like 10 or 12 or a little longer than that in the human nasal cavity. So this gives us a lot of confidence that the use of Profi like once or twice a day could be really helpful in the case of humans. Although we had selected all our excipients and their concentrations based on the IID, the inactive ingredient database, and based on the nasal products that have been used over decades in humans, and we made sure that the concentrations of each component are well below the concentration that have been used in these formulations, which are available currently. We really wanted to still, test the safety of the formulation in the mouse nasal cavity, because we're combining all the ingredients together now in a certain way. So to do that, we dosed these animals every day consecutively for 14 days, and then we took out the nasal cavity and looked at any mucosal irritation or signs of inflammation, which we did not observe any inflammation or any evidence of gross toxicity in the mouse nasal cavity for at least over a period of 14 days of administration here, which really which was really a great support of the safety safety feature of the formulation here. Now, the most remarkable result that really got us excited and got our collaborators excited was this particular study, where we actually challenged the challenged mice with a virus which is known as PR8. So PR8 is a very deadly strain of virus. It's a highly virulent strain, and it's a mouse-adapted strain of H1N1 virus. It's so deadly, just 10 particles of this virus are enough actually to cause a lethal effect in these animals. So we challenged these animals with 25 times the lethal dose of this virus, and then before we challenged the animals with the virus, we either prophylactically treated the animals with pecans, or we did not treat them. And then we observed these animals for survival, for changes in body weight, and then we also looked at the lung viral titer and several other markers of inflammation in the lungs, including cytokines and other things which are actually present. All the data is present in the bioRxiv version of the paper. And as you can see here, what we observed was when the animals were pre-treated prophylactically with pecans, all the animals showed 100% survival up to day 10, while all the animals in the control group, where we did not treat these animals with the formulation, died by day 8. When we looked at the lung viral titer count on day 2 and day 4, in these animals, we saw greater than 99.99% reduction in the viral load compared to the animals that were not treated with the formulation. And similarly, we had great results in terms of the body weight. We saw significant reduction in the count of the inflammatory lung cells, or significant reduction in the concentration of the inflammatory cytokines in the lungs. So this study was really, I think, the key study that got us all like really excited and motivated to move this forward. And this was done with our collaborator at the Brigham and Women's Hospital, who is a world-leading pulmonologist and has all these like extensive models, and been working in this area for like decades, actually.
Thank you, Nitin.
Alex, you want to continue? Yeah, thank you.
Yeah, so that's really all we have for you. So today, Profi is available in the US as well as on Amazon. We just recently opened up Canada as a market, so you can purchase directly through profispray.com. We recommend using Profi once or twice per day, and that means one spray in each nostril is considered a dose. It's not addictive. It does not include any steroids. And in terms of the sensation, there's no stinging. There's really no burning. It's a pretty neutral sensation that lasts for about 10 seconds, and then it's gone. So with that, we can open it up for Q&A.
All right. Well, I mean, that's all you've got for us is a 99.9% reduction in viral load. Awesome. Thank you guys so much for going through that with us. I'm really excited that you did go through the science. And so I will start reading the Q&A from the chat so you can answer some of our questions. And yes, all of our attendees, please type your questions in the chat so that Alex and Dr. Joshi can get to them. Someone else is just trying to come in. Hold on. I don't know where they are. There they are. Okay. So first question. It looks like an amazing product. Now, I have a question for the neutralizing assays. Was there a comparison to a control solution for vortexing and centrifugation, incubation, etc., to get the 99.9% decrease? That's the first question. I'll go one by one for you.
Sure. Yeah. So for all our in vitro and in vivo experiments, we had relevant controls. So for in vitro experiments, our control was essentially so when we are saying 99.99% reduction, that is actually compared to the control where we did not have the formulation, where we just treated the virus with PBS.
And then here's the question that I was anticipating. So you spoke a lot about droplet delivery. Do infectious aerosols work the same way as infectious droplets? Are they trapped into Profi with the same efficiency? So is there a model or reasoning predicting how the trapping of the aerosols would work in comparison to the droplets?
That's a good question. So in fact, droplets are actually the same as aerosol, the way they behave. It's just that, so in fact, in this particular study that I showed you, where we took the 3D printed model of human nasal cavity, there was no way for us to actually create like a human, like coughed droplet. So what we did was we used a jet nebulizer and created an aerosol of those droplets, which had the similar size that deposits usually in a nasal cavity to cause infection. So the size is around 5 to 10 micron. So we used a nebulizer that creates these droplets of that particular size, except for that they had these tiny virus mimicking particles inside. And we measured like how many particles are captured with the presence of our product versus without the product, just with the mucous membrane.
So it will trap aerosols and droplets.
It will both, yeah.
Does it help with allergies? It's going to catch that pollen?
That's a great question, and that's something actually we are testing right now.
Cool.
Yeah, so Kara, I think so. My intuitive feeling is that it will, because as I mentioned to you, we didn't limit our experiments to viruses and bacteria. We wanted to really test the penetration of this very small molecule dye, right? And Profi actually even prevented the transport of this. Now, pollens are actually much bigger.
Bigger,
They are
right.
like in micron size, right? So if you're trapping something which is like nanometer, I think we can definitely trap something which is micron. It's just that we don't have data right now, so I just want to caution that. Yeah.
Yeah, I immediately thought of the dye when with that question. So I'm looking forward to the data. So is it safe for children?
Alex, do you want to take that?
Sure. So right now on the label we state 12 plus, and that's primarily just because the anatomy of children is obviously a little bit different. You don't need as much Profi. So we are going to be lowering that and in all likelihood coming up with a different spray pump that has less Profi per spray.
And I know you guys are asking them and not me, but I'm going to say, looking at those ingredients, there's not anything in those ingredients that would be contraindicated for a kid. Consult your own physician when you use it, but I don't see anything in there that would prohibit its use in kids under 12.
Yeah.
Okay, so here's a question about other things that might interfere with Profi. So I use cromolyn sodium for seasonal allergies. Will it or Profi interfere with each other? And if not, how would I time those sprays? So basically, if you're using something, say, for seasonal allergies or a mast cell stabilizer, and you also want to use Profi, how would you use them both together, and would they interfere with each other?
That's a good question. So I would say that Profi is I think in terms of the composition, the ingredients are pretty inert. So they're not gonna interact with most of the drugs like chemically. Like for example, they're not gonna modify the drugs, I think. The thing is that if you're using an allergy spray, like being it this one or Flonase or something, I would not use it at the same time as Profi because what could happen is uh, if you're using the spray first and then immediately after that you put Profi might try to sort of capture the drug molecules in there. So that could happen. Or if you take Profi first and then you have the drug molecule on top, the drug molecules might not be able to go, cross the Profi barrier. So I would keep like, several, I would not, I think the key would be to not use them at the same time. Alex, do you want to add anything on that?
Yeah, I mean, just don't use them at the same time.
Yeah.
In terms of the gap, I think probably an hour is ideal. If that's not practical, I think 15
Yeah.
minutes still
Yeah,
works.
yeah, that's a good point. I think for drugs, I think, if you're using like an allergy spray or something like that, you could use that first. Give it an hour, like an hour or two, and then use Profi. Don't do it otherwise though,
Yeah,
because Profi is gonna last there for 8 hours or something, right?
that's
So
what I
yeah,
was going to say. Use your drug
yeah,
first, then cover it with
yeah,
Profi. The other thing too, just as you guys ask your questions, Profi is not systemic. It's not like soaking into
yeah.
your nose. Okay, that's how it's making a barrier. So it's not going to like enter your bloodstream and be disseminated in your body to have effects other places. It's going to be a localized thing that's going to stop other things from entering through your nasal cavity and being disseminated in your bloodstream and other places. So questions about like some of the effects of Profi, you need to sort of stop and think this is not a systemic drug. It's a local application, right, guys?
Agreed. Fully agree.
Okay.
Yes.
So what about pregnant women? It's
It's safe for pregnant women, just like you hit the nail on the head. It doesn't get into
right,
systemic
not
absorption.
systemic.
Yeah.
It is safe. We always recommend talking to your physician or healthcare provider if you're pregnant, but from our perspective, it's safe.
Is it estrogenic or progesteronic? Is it safe for people with hormone positive breast cancer? Again, it's not systemic, so it's going to stay in your
Yeah.
nose, right?
Yeah.
What if you predominantly breathe through your mouth due to a deviated septum?
That's a great question. So Alex, you want to take that?
No, you should take it.
No, yeah, so I can, and just feel free to chime in. So, yes, that's a good question. Your mouth also has receptors to which the pathogens can attach. Now, during COVID, there has been a lot of, like science that has come out, which has shown that the number of receptors is way higher in the nasal cavity compared to the oral cavity. So the risk is higher if you breathe via the nasal cavity, via nose, right? So that's why nose is such an important, point to prevent the infections. Um, Having said that, now if you're breathing via mouth, there is a risk, yes. So unfortunately, we don't have a product right now, that can help, but we are thinking on those lines, and I think Alex can step on that a little bit.
Yeah, so there's the oral cavity. While the nose is key, the oral cavity is important too, and so that's an area that we're looking at.
I said, please make a mouthwash. Okay, for the safety test in mice, Profi was applied once a day rather than twice. Is there longer data? I imagine we might be using this forever. So I guess the question is, do you have data if you spray it twice?
So yes, so we do have some data actually that where it's actually very recent data where we actually instill the formulation twice a day into the animals, and then we didn't look at very deeply in terms of toxicity, but we saw the evidence that it's pretty safe. We did not observe any mucosal irritation or anything like that. Now, the reason why we didn't do twice a day in our study, in the initial study, and limited our study to 14 days is purely because of the logistic reasons. It's just very hard because Profi lasts in the mouse nasal cavity for like 8 hours, and then so ideally, if you want to do it twice a day, you want to do like one at time t = 0, and then time after 12 hours. Now that becomes very complicated in terms of like postdocs and students really like instilling this after 12 hours. And also, if you think from a mouse perspective, now most of the treatments in mouse done for 14 days are pretty long treatments actually, because it's just a small animal, the lifespan is much smaller, right? So 14 days, so in terms of biocompatibility and safety, if you demonstrate safety in mouse for 14 days, that's really like commendable, and that really shows that really supports the fact that this could have like a safe profile in humans later on. Yeah.
So instead of translating into dog years, we're translating into mice days. Yeah. Age equivalence. All right. How are your ingredients different than the sprays with iota carrageenan?
That's a good question. So we have actually done comparisons with iota carrageenan in our paper. So we did in the in vitro studies, we compared iota carrageenan head to head, and we saw much lower efficacy with iota carrageenan on its own compared to the efficacy that we saw with our formulation. If I remember clearly, I think we saw around 2 log-fold, which is equivalent to like, I think, 90% reduction in the viral count compared to 99.99% that we saw with our formulation. And then there is also a published study, if I'm not wrong, somewhere where it was done, I think, in the same PR8 mouse model, where they instilled iota carrageenan and also I think kappa carrageenan for several days, and then they even after the infection, and then they observed only 70% reduction in the lung viral load. So we think, based on the data, that Profi has superior activity compared to iota carrageenan. Also, iota carrageenan doesn't work, or has not shown to work, at least to date, on bacteria and such a wide, broad spectrum of viruses that we have shown the efficacy against. Yeah.
Any plans for research on human? Oh, I'm sorry, Alex, did you want to add to that?
Well, I was just going to say, and the mode of action as well. My understanding is, we're the only nasal spray that also has considered capturing of respiratory droplets.
Agreed. Yeah.
Just the barrier. So,
yeah, that's true.
So iota carrageenan is antimicrobial. It kills the things, but it doesn't trap them. And Profi
doesn't trap them, and it doesn't trap the respiratory droplets, actually.
Right. But Profi traps and kills. So
yeah.
Any research with humans, or any plans for research on humans?
So I can take that one. In all likelihood, we won't pursue human trials, and the rationale for that is just, they're kind of risky, right? When you're, I guess there's a couple of different ways you can do it. The human challenge studies is when you deliberately subject an individual to a pathogen such as coronavirus. They can be dangerous, they can be risky, and frankly, I don't know if the FDA is allowing for that. And so the alternative is you need a lot of people with a really, really high infection baseline. So they're super expensive. What we have seen from some of the other nasal sprays is because proving prevention is so difficult, they've kind of moved into more of reduction in severity and the number of days where you're sick. And so I don't know if that answers your question, but
well, there was another question on, are you going to test to see how long it actually stays in the human nasal cavity? So not necessarily against.
That's a good question. Yeah, I think we would love to. The problem is that, it's just so hard to actually like determine the residence time in the human nasal cavity. What we could determine in the human nasal cavity is really, what frequency of Profi use gives us an ideal post-exposure prophylaxis. For example, if someone got the virus and then uses like Profi twice a day or once a day, I think that is possible because the pre-exposure is just in general hard because of Alex's point that he mentioned that you need a very high baseline infection. So we'd love to test the nasal residence time, but to test nasal residence time, unfortunately there's no direct easy way to do that in human nasal cavity.
Okay. How does it affect the natural healthy bacteria in the nasal cavity? So your nasal biome.
Yeah, that's a good question. So we do not have a perfect answer to that. But what I can tell you is, again, if you look at the ingredients that we have used have been used in many products which are currently available commercially, clinically, and and people can use those, and they're recommended to be used for like 6 months at a stretch, like every day. And there are no reports, there have been no reports that really shows any evidence of changes in microbiome that can lead to any detrimental effects. So even if and the other point is that the microbiome in your body in general, like healthy in healthy bodies, can replenish pretty quickly. So like Profi, even if Profi might have effect, it might not lead to any like major detrimental issues based on the safety of the ingredients that we have.
And then we have a few questions about, again, the smallest droplet size. Was it 5 microns? You probably want to talk about the smallest droplet size that you used, as well as the size of that dye that you used that couldn't get through. We're having a lot of questions still about like the aerosols versus the droplets for the microns. How small of things does Profi trap?
So the droplet size, so I would like to emphasize that the droplet size and the size of the viruses are very different. The reason is because the virus is actually sitting inside the droplet. It's not like one virus is sitting inside one droplet. It's like multiple viruses. You're basically, like coughing or sneezing, and then you're creating all this like burst of aerosol, right? When you cough or sneeze. And these are like the droplets that and you create like lots of different sizes of droplets. The droplets range from I think from hundreds of nanometer to like several tens or twenties of microns actually. Now the key here is that the droplet size that really deposits in your nasal cavity is 5 to 10 microns. So that is the reason why we focused on looking at the droplet size within that range, because your nasal cavity has the highest number of those receptors that can really cause the infection. And then for the capturing of the droplets that we studied was within the range of 5 to 10 micron because of this reason. And the virus particles are like less than 100 nanometer, maybe like 50, 60 or less, or even like 20 to 50 nanometer maybe. But they're very much smaller than, like those 10 microns droplets. So Profi captures 10 micron size droplets. Profi captured or prevented the transport of 20 nanometer, 50 nanometer virus particles. And Profi also prevented the transport of a dye, which is basically just in angstrom, a molecule. So like 10 to the power minus 10, essentially, yeah.
So it traps almost everything.
We were pretty surprised with the dye, actually, Kara, honestly, yeah.
So in the transport study showing the 99.9% decrease, was that done at room temperature or body temperature?
That was done at 37-degree body temperature, yes.
Have you looked at the relationship between particle charge and capturing? Interesting.
Yes. So if you're talking about capturing of the pathogen, so the way we, advanced the project was, we did the screening first, to look at what ingredients can really maximize the capturing of the different pathogens. And what we found that there is definitely a charge relationship there. And that's why we have so many ingredients. So just to give you an example, if you remove pectin from our formulation, you will lose the efficacy against even transport neutralization against influenza A virus, for example. If you remove BKC from the formulation, the Profi is not going to be active anymore against SARS-CoV-2 or some of the bacteria. So there is like a charge dependency, but I would say that it's not purely because of charge dependency. There are some other interactions that we have identified in the bioarchive version of the paper, which we found through computational modeling, that are happening between the proteins on these pathogens and the components of Profi. Yeah.
Great question, Anna.
Yeah, this is a very good question.
Right?
Yeah.
Okay, so we've talked about killing and binding the contaminants. We want to know, what is the percentage killed versus the percentage bound? And what happens, for example, if you have a bound COVID virus in your nasal cavity?
So that's also a very good question, a tough question, I think. So we have not looked at, when you have Profi, how much percentage is killed, how much percentage is bound. What we have done for certain viruses, not for all the viruses, by the way, is we have done PCRs, to really look, if the virus was actually like neutralized or, or it was just captured. So we have seen that when we did the transport studies, right? So there we were purely looking at the binding, because we are looking at, how much virus actually comes inside, right? So we saw almost 100% because we saw like greater than 99.99% prevention in the transport. So it's like almost 100% actually was, bound, right? When we did the neutralization experiments, at that time, we are not creating a barrier. We are just like mixing the thing and then treating the cells at that time. So we saw 100%, protection, neutralization at that time as well. So, and then based on the PCR and other, studies that we did to quantify the neutralization, and also we have some of the imaging studies that we did to look at the virus membrane, where we saw the destruction of the virus, with the components. We also saw all those things. So yeah, so I think my short answer is we have not looked at like separately, like what is the percentage, but when we did individual experiments, we saw 100% in both cases.
And so if you have a bound virus in your nasal cavity, and basically eventually whatever's in your nasal cavity, sort of washes down your throat and then throughout your digestive system, those coronaviruses that are bound or neutralized in your nasal cavity, what if they're not neutralized? What if they're just bound and they get into, this is actually a question that I already asked them, so I'll let them answer, if they go into then your stomach and your digestive tract?
Yeah, so I think once, I think if you have the virus, trapped in, in the formulation, we know that it's not going to be active, right? Because it's bound now. So when we say binding, that really means that Profi is not just like binding it electrostatically. Profi is actually binding one of its spike proteins. So it's not now freely available to enter the host cell. So even if it gets cleared, it's just going to be cleared. It will not be able to bind to any of the receptors in the rest of your body, really.
Yeah, so basically the spike protein has to fit in the receptor, and Profi makes the spike protein not a shape that won't fit into the receptor. So
exactly,
if you had a ton of virus that was attached to Profi go into your digestive tract, it would not be able to get into your cells, because now that spike protein's a different shape and it won't fit into the ACE receptor.
That's correct. And then if this would have been true, in our mouse studies, right, where we treated the animals prophylactically, if the neutralization would not have been enough, we would have seen actually infections, right? But we did not really in that particular case. So, yeah.
So, Gertie, I think we've answered all these except for, does it get inhaled into the lungs?
No. So we are using a very standard nasal spray formulation from one of the top, companies, who develops this in the world. And this particular device it has been engineered to really create a droplet size that deposits the formulation only, or the droplets only in your nasal cavity. It does not take it to the lungs.
All right, Amanda, I don't know who you're directing to. I don't know if these guys even have kids, but the question is, would you use it on your own 5-year-old? I can tell you if I had a 5-year-old, I would use it on my own 5-year-old with the current nozzle, but would you guys use it on your own 5-year-old?
Okay, I don't have kids, so I'll give it to Alex.
So personally, yes, but I think for now I would stick to the script and say, just based on the labeling, today it's 12 plus, but that's going to be going down soon. And I also saw a question somewhere about side effects and contraindications. So today there's no side effects, there's no contraindications. We simply, in terms of warnings, we indicate that if you have a sensitivity or allergy to any ingredient, of course, don't use Profi. And if for whatever reason you experience nasal discomfort or irritation, discontinue use. And that's really it.
So here's another good question that we've talked about a little bit, but this will be good because I know a lot of people in the group might be interested in this. Can it be used in conjunction with other COVID preventive nasal sprays? So if someone wants to use iota carrageenan or Enovid, can they somehow layer these things with Profi? Who wants to take that one?
Yeah, I think I can take it, and then Alex can chime in. Yeah. So I think it's the response is probably similar to like the drug question that was asked before. I would say that I would avoid using it with other like things in just in case, because we don't know the interaction. It's not going to interact chemically for sure, but I think if you're using the other spray for a specific purpose, then you just don't want to compromise its efficacy or Profi's efficacy. Profi will definitely maintain its adhesion ability, I think, even if it is used with any other nasal spray. But but it's just, I think, one thing you have to be careful about, especially with the other chemoprophylactic nasal sprays, is because some of them might have a mechanism of action which is a subset of how Profi works, right? Because Profi has this multi-modal approach. We are trapping things, we are neutralizing things, but then many nasal sprays are not doing like all of it, but they're doing like neutralization versus trapping or something. So in case the mechanism is similar, and if there is a charge-based interaction between the two, then it could really, really cause a problem. Because even in Profi, by the way, there's a little anecdote I can give it to you. When we were developing Profi, so we have like these 5 ingredients, right? Now the way you add these ingredients to water matters. For example, if you add A, then B, then C, Profi will work very well. If you add A and then C and then B, Profi will not work, because A and C have a high chance of interaction together. And if they interact, they're not going to be able to, operate very smoothly after that. But if you have B in between, then that really prevents the interaction of A and C. So you see my point. So if you have like another, nasal spray that you're using, which has a potential to somehow interact with Profi, it could really compromise, both efficacy, I think. So I would avoid it. Yeah.
So your advice would be just use the Profi instead.
Yeah, just use Profi or just use something else, whatever. Yeah. Use Profi though.
Did you have anything to add to that, Alex? Or
no, that was a good answer.
Okay.
Yeah.
All right. So here's a couple of questions that sort of go together. For COVID protection, how would you imagine using Profi in the real world? And do you use Profi yourselves?
Oh, all the time, every day.
All the time.
Yeah, sometimes multiple times a day.
Yeah, I use it like twice a day, and then when I'm traveling, yesterday I was in New York, I took the train back, and then I sprayed Profi into my nose just before I took the train. Yeah,
so you're both daily users of Profi.
Yeah.
So you would imagine in the real world, everyone just sort of daily uses Profi so that they get that extra layer of protection against pathogens. Okay, Profi eventually gets swallowed. Do you recommend blowing your nose at the end of the 8 hours?
It doesn't really matter. I think it's just going to be cleared by your digestive tract. So yeah.
Can you spray it as a throat spray? So could you spray your nose and then spray your throat?
You could. We haven't really tested it.
So
we obviously we want to look at that in terms of the efficacy, but I don't think it would do any harm. Nitin, what do
Yeah.
you?
Yeah. No, I actually tried it, once, and it won't do any harm for sure. It's just that I'm not sure if it's going to be effective, because it's just the reason the spray is not designed as a throat spray, the device there. So throat sprays have usually like a different kind of device. Yeah.
Okay, here's a litmus test for you guys. Wayne's not going to let you off the hook. What precautions do you currently take for COVID and other respiratory illnesses?
Vaccines, Profi, and masking.
Yeah. All three.
All right. Apologies, I remain confused about the terminology. It sounds like testing was 5 to 10 microns. Are there, which are conventionally referred to droplets rather than aerosols? Are you planning to test for 0.1 to 5 micron sized aerosols?
Yeah, so when the nebulizer actually creates the droplets, and 5 to 10 is really called the mass median aerodynamic diameter. It doesn't mean that there's strictly like we have 5 to 10, and so it also has like some in 1 to 5, some actually like higher than that particular range, right? But it's just the maximum population that it has is 5 to 10. Yeah, so we could test it, but the only reason we did not was essentially, that's the most prominent diameter that has been reported to cause deposition in the nasal cavity.
Could you give us a little rundown, I think, because they're asking about the mechanisms between how does the product neutralize the virus? So, like, I know that different components of your nasal sprays work, like you said, on different pathogens. So, I guess maybe because we're concerned about COVID here. I mean, personally, I'm concerned about like a lot of other things. Like, I'm really excited about this because when the bird flu comes along and jumps into humans, I'm going to be like bathing in my Profi. Just kidding. but particularly with respect to COVID, which of the ingredients are working on COVID and what is it actually doing? So you've already mentioned that some of the ingredients are binding to the spike protein so that it does not fit into a receptor. Is there other actions of which ingredients that neutralize the virus?
Okay, I can give you probably like a detailed mechanistic analysis of the formulation. So gelin is the formulation that really is essential for your transport prevention. So if you remove gelin, Profi will not be able to prevent the transport of the pathogen. So when we had studies, done in the absence of gelin, we saw 100%, like going, inside to the bottom chamber, right? So gelin is important for preventing the transport. You have tween, which is polysorbate 80 there. Now, polysorbate 80 is doing three things actually. Number one is it really increases the capture of the respiratory droplet. So it is a surfactant. So what it does is it minimizes the surface tension on your nasal cavity, on a nasal wall. So any droplet that comes there, it doesn't bounce off, or it minimizes the chances of it bouncing off. That's number one. And then the second thing is it's responsible partly for the long residence time that we have. So if you remove tween, polysorbate 80, you will not have that kind of long residence time in the nasal cavity. And number third is, for some of the viruses, including SARS-CoV-2, it actually helps destabilize their membranes on the top. So that's one of the ways it actually, like Profi, works against SARS-CoV-2. And then we have BKC, which really binds to a lot of spike and nucleocapsid proteins on the SARS-CoV-2 surface. And by binding them, it really prevents it to sort of interact with the receptors or the entry checkpoints in your nasal lining. Is that good enough, Kara?
Oh, that's awesome. Thank you. What if you're already infected with COVID? Would it make sense to use it while you're infected with COVID? Would it help you reduce your viral load?
So we have not done testing on any post-exposure prophylaxis, but we think that if you use Profi early after you have got infected, if you know you have got infected, by the way, like within a day or so, we think that it might help to reduce the severity of the disease. but we don't have like any like solid data. And that's why, a lot of other nasal sprays have actually, moved to the post-exposure prophylaxis because it's easier also to test on humans, right? And many formulations have, that have been previously developed actually have shown capability to, especially against the flu virus, to really reduce the severity and the duration of the disease when you use them like within a day or so. So we think that Profi will also be able to do that. Because let's say you have the virus still in nasal cavity, right? And you spray the Profi on the top of it, it will still be able to neutralize, and trap some of the pathogens that are there, right? So that's the mechanism on which I'm basing that, it's gonna reduce the severity after
There's
COVID.
also
Yeah.
some rebreathing, there's a rebreathing variable.
So we discussed that, yes. So we also think that it might actually reduce the aerosol that you generate if you are infected, which actually prevent others from getting infected, even if they're not using Profi. But again, we don't have like strong data, and we don't want to be like the same thing right now. Yeah.
Oh, and I saw this question earlier. I missed it. I'm sorry. On the box, instructions say, do not use for longer than 4 months. Please address. What does it say?
You know, Alex?
Don't use it for longer than 4 months.
So I think that's where we looked at the concentration of our ingredients and really just looked at warnings on other commercially available nasal sprays and tried to follow suit out of an abundance of caution. And when we say 4 consecutive months, that just means take a day off, take a couple of days off, and then of course you can resume using Profi.
So answering this question would really require, like detailed long-term toxicity studies in humans, right? But, we leveraged the fact that, these ingredients have been previously used in products that are used on a daily basis for several months. So we looked at those products where these ingredients are there and have been used at similar concentrations. And those products had guidelines for use 6 months at a stretch. And we wanted to be just cautious. So we had definitely has to be less than 6 months, and we just sort of overcautious of 4 months.
So it's a regulatory instruction, basically.
Yeah.
You don't really have evidence that after 4 months it's going to do something different than it does at 3.5 months. But because the data only supports use for 6, you're going with 4 in an abundance of safety precaution. Okay, great. There's nothing in there that's going to blow up your nasal cavity after 4 months.
No.
All right. Okay. Based on the info regarding what is trapped and what's deposited in the nasal pharyngeal passage, it's unclear whether this can be so much more effective than any other nasal spray that also captures such droplets while smaller aerosols go deep into the lungs. So I think, again, we're not you want to go ahead and take it? You had something?
So I would like to just add one point that, there's no other nasal spray formulations that can actually capture respiratory droplets right now.
Right. And you already said it can capture aerosols, right? It's capturing the droplets and the aerosols. It's not like the aerosols are speeding past it into the lungs.
Yeah.
Aerosols
so essentially when someone coughs, sneezes, they're essentially creating these aerosols that consist of the droplets. So aerosols is like a broader term for the entire thing that is created, and the aerosol consists of these tiny droplets. Yeah.
Well, I'll just so you know, Nitin, in our community, the droplets are what justified the 6-foot rule. That doesn't, we know is a really bad rule because the aerosols go farther. So people in our community are not used to thinking of aerosols as containing and smaller particles. That's why they're confused. They're thinking of aerosols as a certain size of particle that goes past 6 feet and can, linger in the air for hours at a time. That's where the confusion is. And so people, I think, really want to be sure that it's not just those big droplets that fall out of the air at 6 feet, that it's actually getting the smaller aerosols in there. So there might be some terminology difference in biomed versus aerosol engineering is what I'm hearing.
Yeah.
So is Dr. Joshi saying that capture from air is felt to be equally efficient by Profi across all airborne particle sizes? This might be also a question about whether the human airway delivers different size particles to the mucosa. So I think that's what we just talked about.
Yeah.
It works efficiently across all airborne particle sizes.
Yeah, I think I would say that, so the particles, again, to emphasize this, I think the particles that are most critical, for for causing the infections are really the 5 to 10 micron, droplets. What happens is when when you have the tiny droplets that you're talking about, like they linger, they could so if they're just like lingering in the air, there's a chance that they can deposit in the nasal cavity. Yes, and in that case, Profi will definitely be able to capture them. Now, when you have like a new aerosol, like droplet generated after coughing, the tiny particles, which are in the nanometer range, what happens to them is really they go into your deeper lungs and then they are exhaled back because they cannot, because of their size, they cannot be impacted really. Does it make sense, Kara?
Yeah, I hear what
Yeah.
you're saying. If something is so tiny that it flies in, it will fly right back out when you breathe
exactly. Yeah. Yeah. Oh, I hope the reviewers of our paper don't ask these tough questions.
You want peer review, you can come here.
Yeah, so our paper is actually sent out to so it sits with one of the top journals right now. It's in the review process. We'll update you guys as soon as it's accepted.
Okay. Okay. Once the bottle has been used once, when should it be thrown out? How long can you use it and keep it on the shelf and use it again? What's the shelf life after it's opened?
So it's 2 years from the date of manufacturing, which means typically by the time a customer receives it, it's at least 1 year of dating. It doesn't matter if it's been used or not. And one thing you guys should be aware of is the white spray actuator can be removed. You can just pull that white thing off the top and rinse it if you need to, and put it right back on.
So even after you open it, it doesn't matter if it's opened or closed.
Correct. Yeah, once you've used it, it's still 2 years from the date of manufacturing.
Okay. All right. Do you mask and Profi, or did you go to New York without a mask?
We recommend both. Profi should be
recommend
viewed
both.
as an additional layer of protection.
Yes. Does Profi preclude the need for a mask, or is it more of an adjunct to masking? We just answered that. Do you need to reapply after you sneeze or you blow your nose?
That's a great question. So I would say that Profi really forms like a strong barrier there. It really sticks to your nasal mucosa unless it's cleared along with the mucus. If you blow your nose, you can certainly apply it again to be just 100% sure, right, Alex? I think that's what I do at least. So
I think some of it depends on timing too. If you spray and sneeze within seconds, you're probably going to want to apply Profi again.
Yeah. You should definitely blow the nose before you apply Profi. That's what I think. That's what I do. Yeah.
Okay, now there's a large discussion again about this whole aerosol thing that I think, again, we're getting confused, people. Someone says, okay, the takeaway is Profi can block droplets, but not aerosols. So smaller aerosols will make it deep into your lungs, but not the droplets. That's not the takeaway. The takeaway is that Profi traps wherever the virus is capable of infecting you and binds it up and then neutralizes it. It blocks droplets and aerosols in the way that we use the word aerosols. Well, the way that Dr. Joshi uses the word aerosols is everything, both large droplet particles and tiny little small aerosol particles. He uses the word aerosols. I mean, droplets aerosols contains it all. So we're having a terminology issue, folks. They're saying that Profi can trap things that are much smaller and much tinier than aerosols. Limiting factor for all nasal sprays. I think all of the mice got sick, just less sick later. And so when the mice lived past 10 days, your mice, when you have all the mice that weren't treated and they died at day 8, okay? The ones that lived past 10 days,
they lived,
did they ever get sick? No, you killed them and then studied them, right?
Yeah, we have to euthanize.
Yeah,
we have to euthanize the animals at the
right.
end to look
and you have to then check and look at their nasal cavities and see if there's any lung inflammation and test their cytokines and all of that.
I mean, you can look at the data at day 2 and day 4, right? I mean, day 2 and day 4 is just like you're seeing greater than 99.99% reduction in the lung viral titer, and if you see that at day 2, day 4, it's very unlikely that you will see it later on.
Yes. So the mice did not get sick. Only the control group got sick. The Profi group did not get sick.
No.
To be clear, is Dr. Joshi saying near 100% of aerosols, droplets, everything that might contain viral particles are able that are able to seed infection are captured by Profi? Yes, right?
Yes. So if the particle is impacting on, so this is the answer. So if doesn't matter if it's aerosol or droplets, if the particle is impacting onto nasal cavity, the Profi will be able to capture it. Is this an answer question? Yeah.
Yes, that's a great answer for the question. Maybe that should be a blurb on your website or something. If it can,
I like that. Yeah.
If the particle impacts the nasal cavity, Profi can capture it. That's great. That's a great one. Can I volunteer to be part of an allergy study?
Sure.
We need volunteers.
Yeah,
Yeah,
I mean, we'd love to get everybody Profi.
We need to have IRB in place. Yeah,
absolutely.
But okay. You've been on the market since December, right?
October.
October. Okay.
Yeah.
October. All right. Okay, here we go again. I don't think it's a terminology issue. Trying to clarify that what's being said is that anything breathed in that could possibly cause infection is either trapped by Profi or it does not deposit and is immediately exhaled again.
Yes. So if a particle if a droplet or aerosol impacts the nasal cavity, Profi will capture it. Now, the things that really escape the impaction nasal cavity are the particles which are really small in size, and they tend to go into the deeper lungs. They will go there, but most of them are just going to be exhaled back, so they're not going to do anything. Now, there'll be some fraction of particle that will remain in deeper lungs, but the key here is, and why people say nasal cavity is so important, is because your deeper airways do not have such a high density of entry checkpoint receptors to which the virus can attach. So even if, let's say, some of the particles end up into your lungs and then, remain there, the chances of you getting infected is much lower. The infection usually starts in the nasal cavity. Does that clarify? So yes, so overall, yes. If there could be some particles, a small fraction of the smaller particles that go inside, but then the majority of that is going to just come out, and a small fraction might remain in the lungs, but the likelihood of that causing an infection is very low. So if the particle is impacting the nasal cavity, Profi will capture it.
Thank you. That clarifies, and it's important for us to know to determine how this fits into our precautions.
Cool.
All right. So, are we ready to go ahead and give the attendees here their discount?
Yeah.
All right.
Let me share my screen again. So first of all, thank you, everybody. That was wonderful, and I'm amazed by the questions.
Yeah, me too. Yeah.
I warned you guys.
Yeah.
Yeah, no, when we were preparing the slides for this, I was telling Alex, I think we need to explain science really deeply here, because this community really loves science, so it's great.
Our lives depend on it.
Absolutely.
Yeah.
Absolutely.
So